So we know that sound is a set of compressions and rarefactions, as you can see, and a better way to represent that is as waves in this format, where you can see each compression as a peak and each rarefaction as a trough. So we're going to take that wave, keep it in front of us, and we're going to define certain quantities. The first one being the distance between two crests or two troughs. You already know they're going to be equal, right? The distance between two crests and two troughs is going to be equal, and that particular distance is what we're going to call a wavelength. So it's the length of this wave. Another thing we're going to define is how many such crest trough pairs. We take one crest and a trough. That's like one wave, because after that that keeps repeating. So that one crest and one trough in 1 second or in 1 unit of time, usually it's a second, how many times does it occur? So if you have 3 of them occurring, right, in a second, right, 1, 2, 3, then you have a frequency of 3. If you have 4, it's 4, and it's beginning to get obvious now, isn't it? So your frequency, which is the number of crests or troughs in a unit of time, usually a second, and wavelength is the distance between two crests or two troughs. And now you have to calculate something called time period, right? Now it's very easy to calculate that that's going to be exactly 1 by the frequency. Now why is that true? From now, let's just call it waves, okay? Yeah, a crest and a trough put together, let's call it one wave. So therefore, let's say I have 5 waves in 1 unit of time, in 1 second. Then what is my frequency? Yeah, 5 in 1 second, therefore the frequency is 5. But now if I were to ask you, what is the time period? In other words, how long does one wave take? This goes back to the old question, right? 5 mangoes cost 20 rupees. How much does 1 mango cost you? Yeah, you would do this pretty easily, wouldn't you? If 5 waves take 1 second, then 1 wave will take 1/5 of a second, right? It's exactly what it will take. If 10 waves take 1 second and the frequency is 10, then how much will the time period be? 1/10. Do you see the pattern already? Frequency is going to be 1 by the time period, or time period is going to be 1 by the frequency. So they're related as inverse, and it's very logical as to why that is true. So we've defined 3 quantities here: time period, the time one wave takes to complete; second, the frequency, which is the number of waves in a particular unit of time, usually a second; and wavelength, which is the distance between two crests or two troughs.